And tan theta, you can do this one for me, Daniel. So this is my theta guy here. So what's my opposite over adjacent going to be?
5 over 12.
Easy, 5 over 12. Now, can you leave a couple of lines here, because we're going to come back to this, okay? Sine 90 minus theta. Okay, so this one was a little bit different, right? I had this triangle here, and I said the opposite, the adjacent over the hypotenuse is 5 over 13. Sine 90 minus theta, I'm looking at this angle here. I know that's going to be the opposite over the hypotenuse. That's going to be 12 over 13. But what do you notice about the placement of what I've created here? I've got sine theta, and I've got cos 90 minus theta. What do you notice about
the theta in the other spot?
Yeah, right. These two are actually the same triangle, right? Because all the angles in a triangle add up to 180. Okay. If this is 90 and this is theta, then that would have to be 90 minus theta. Okay. And so that's why these two triangles are actually the same. And this is a proven identity. So sine theta equals to cos 90 minus theta. It doesn't matter what angle, what theta you have. This is an identity you can always use. And conversely, cos theta, what's that equal to? Well, that's also equal to sine 90 minus theta. Can you write that down for me under complementary results?
Is that why we left a few lines?
No, we're coming back to that. Okay, so how do we actually use these complementary results to solve problems? So this is one of the biggest differences between general and two unit. In general, you're really focusing on finding the sides and angles. In two unit, we want to look at the relationships which exist between these ratios. I'll give you an example. So something like this.
Thank you. Encouragement.
Okay, first example. If sine theta equals to 8 over 10, find cos theta and tan theta. Okay. So the first thing you want to think about, okay, what are sine, cos, and tan? Well, they're just trigonometric ratios, right? So this is saying that sine theta, the opposite over hypotenuse, that's equal to 8 over 10. First thing you want to do is you want to create a triangle that represents this scenario. Okay? So you've got some right angle triangle and you've got theta, and you know that sine theta is the opposite over hypotenuse, right? Opposite over hypotenuse. And what did you get for that, Keenan? 6. Okay, so you can use Pythagoras to work out this other side, and you'll get 6 for the missing one. And then you can just fill in the other results. You know that cos theta, well, once you know where theta is, it's really easy. You've got the adjacent over the hypotenuse. That's a over h equals 6 over 10. And same with tan theta. That would just equal to opposite of adjacent, 8 over 6. I use Pythagoras' theorem. Yeah, Keenan did it really fast, eh? One thing to note, again, in 2 unit, we love this idea of an exact value. So don't get tempted to put this into your calculator. Just leave it as the fraction form, okay? We prefer to leave it like this. No, so 10 squared minus 8 squared, what's that?
36.
Yep, so square root of 36. Good. Okay, let's have a look at another one.
Hey, how do you know when it's plus or minus with Pythagoras?
Well, the idea with Pythagoras is you can't have a negative length. Okay?
Yeah.
You can't have a negative... Oh, how do you know to subtract them?
Yeah.
Oh, because the hypotenuse is the longest side. So literally the square...
So when you find the hypotenuse is plus.
Yeah, the square of the two sides is equal to the big one. Good?
Yeah.
So again, we want to use these complementary results to help us prove certain things, okay? So, the first thing is they're asking us to show using the results that sine 70 is equal to cos 20. And I think some of you might be able to observe that, oh, okay, it kind of makes sense if I just look at it there. But they want us to actually write it down very logically, and that proves to the marker or whoever you're showing that you understand how these work. So the first thing is you want to start with your left-hand side. You've got sine 70. So that's my theta, okay? So this is my sine theta. And I know that sine 70, well, that's equal to sine 90 minus theta, which in this case my theta is 70. Oh, sorry, cos. Yeah, thanks. Cos 90 minus 70. And what do you end up with? You end up with
20.
easy.
That's easy.
What is this? 9.
Okay. Cool. Can you have a go at this next one for me? We're going to use our complementary results here. First things first, you want to try and change one of them to be the same as the other. So I want to use my complementary result to have sine 65 equal to something else. What am I going to get? Oh, I think I made them. Yeah, no, that's right.
25.
So 25. And then once you have that, if you know sine 65 degrees equal to cos 25
That's
degrees.
just 1.
Exactly, right? So you can substitute that in as cos 25 over cos 25.
Which is 1.
Easy.
Let's do the whole 1.
Because I've got one thing divided by another thing, that's the same thing, that's just equal to 1, okay? If you're still a bit confused, just remember that the complementary results you wrote down, those are kind of like laws, okay? We can always do them, doesn't matter what these numbers are, okay? We can always use them, okay? So I've got sine 65 is equal to the complementary cos angle, which is cos 25. And then that's what I have in the numerator. Cos 25 by cos 25, that's just 1.